Hi, I'm Ron Dimitrovic at EPRI's Knoxville Laboratories. Welcome to the Thermal Environmental Testing facilities here in Knoxville. This lab supports efforts in energy efficiency and demand response, primarily by enabling testing of heating, ventilation, air conditioning, water heating, building envelope, and waste heat utilization systems. Thermal loads are somewhat unique in that they are very dependent on the temperature conditions in which they operate, and thereby they depend on the geographic region in which they operate. And those conditions are different in different utility regions and in different parts of the country. What we offer here is the ability to characterize equipment in those specific regions and temperature conditions. The primary piece of infrastructure is this dual room climate chamber, where we can control indoor and outdoor air conditions for testing and evaluating air conditioning components. We have full temperature and humidity control. The outdoor room can range from approximately -10 degrees Fahrenheit up to approximately 120 degrees Fahrenheit with full humidity control. We have several pieces of equipment under test. Let's look at a low temperature heat pump in the outdoor chamber. This is a low temperature variable speed air source heat pump designed to provide full capacity down to approximately -5 degrees Fahrenheit. It eliminates the need for electric resistance backup heating and reduces the demand that electric resistance backup heat can have on wintertime peak demand. It also allows efficient heat pump technology to be used in more northern climates in the United States. This is the outdoor unit. It's instrumented to measure performance. Let's go look at the indoor unit. This is the companion indoor air handler that you might have in your house or in the ceiling above your work. Air returns to the bottom and flows up through this ducted test section where we monitor air flow rate. We measure return air temperature and relative humidity, supply air temperature and relative humidity. Data from these sensors is fed through our central data acquisition system and onto a computer for processing and analysis. In addition, we're setting up to test several dehumidification systems. This is a Munters Dry-Cool HD hybrid dehumidifier, which is appropriate for a residence or a small commercial space. It provides separate dehumidification to work in conjunction with a regular air conditioner for applications where dehumidification is needed, in particular the southeastern and eastern United States. Back in the outdoor chamber, we're testing a similar technology with a liquid-based desiccant system manufactured by Dehumidification out of Israel. It uses a lithium chloride liquid desiccant to do essentially the same thing, that is, pull moisture out of the air separately from controlling air temperature. These desiccant dehumidifiers allow you to separate moisture removal from temperature control, providing for better comfort at higher efficiency. This facility has been instrumental in allowing us to leverage research dollars from other institutions such as the Department of Energy. We continue to use this laboratory for performance mapping of thermal systems. Controlled laboratory testing in conjunction with field monitoring and analytical methods allows us to provide the information our clients need for the successful implementation and operation of energy efficiency and demand response programs.